Good morning and welcome to the latest Layer 123 speaker soundbite. Today it gives me great pleasure to welcome Kurt Pynaert, the head of the end-to-end SDN solutions team and Bell's Lab Fellow at Nokia, and an upcoming speaker at the Layer 123 slicing webinar. Welcome, Kurt.
Thank you.
Pleasure having you here. So with the rollout and uptake of 5G across the vast number of industries, we're seeing the crucial role of network slicing in empowering service providers to offer innovative services and expand into an array of new markets. Kurt, what is your view on network slicing and what is it about in relation to 5G rollout?
Okay, so let's start with indeed spending a few words on what network slicing is in the 5G area. So actually, network slicing is to share a physical network in the most economical and effective way amongst different tenants. Now, what makes it so specific for 5G is that 5G is coming with a new set of services with diverse requirements. So it's not only about speed and bandwidth, but new services in the context of 5G require as well latency, ultra low latency, ultra high reliability. And actually to transport those new services, 5G services over a network in the slicing context, each slice needs to be configured, provisioned, assured, optimized for that specific set of requirements, which are quite diverse amongst the different services. This is not only for providing mobile services, but this is also about using 5G and network slicing for industrial automation, Industry 4.0, for fixed wireless access, public safety, sensoring, so collecting massive data, e-health, and that sort of things. So in summary, it's actually utilizing the network for the specific different services which are coming along with 5G. Now, we could do that the same as we did in the 4G era, but in 5G, the one size does not fit all. So actually in the pre-5G era, we transported actually low bandwidth, high bandwidth gaming, metering, video streaming within the same sort of pipe. But in the 5G area, because they have all specific requirements, we slice actually the network so that each service has their own slice in the network with their specific characteristics. What is important as well is that providing a sliced network in the 5G area, that things like service level agreements are catered for. So service level agreements not only about bandwidth and speed, but also in terms of latency. So if there's a low latency service, that indeed the network is devised in a way, or the slice is devised in a way that this low latency is provided and assured for and optimized for. Same, for instance, for reliability. Because, for instance, an application of e-health using network slicing, and no need to explain that this connection, if I may, needs to be very high reliable. In all this, so network slicing in the context of 5G automation is actually a necessity. It's very essential, because such different characteristics you cannot do by using manual creation of a network slice. So automation is very key in network slicing. Yeah.
I know you touched upon, Kurt, the different characteristics of network slices. How would you, maybe go into a little bit more detail on the different characteristics that you define within network slicing?
Yeah. So actually, the different characteristics, we are all used to speed. So the speed of the internet, the speed of high-speed internet, the speed of downloading video, streaming videos. So which is still, of course, a key characteristic. But actually, it's not only about speed and bandwidth. I think it's wrong to think that over time only the bandwidth will increase. If you look into applications of e-health, as I was already referring to, or Industry 4.0, automating industries, smart cars, then latency is much more important than speed. So even that service can have very low speed, but very low latency as well. So latency is a very important characteristic in the context of network slicing and 5G in general. Not only speed, bandwidth, latency, but also reliability. So as I stated already, if you are using the network to set up an end-to-end slice, for instance, for doing an e-health application, yeah, the communication and the slice needs to be very reliable. And that's what actually the network slicing or the network slice needs to be devised for. And that also implies that it's not only setting up actually the network slice once, but it's also continuously monitoring the characteristics of the network slice to make sure that the service is delivered according to service level agreements. It's about security. So the moment you start sharing actually a physical network among different tenants used for different services, security is key. So actually the isolation and the security of a slice is very important in this context. It's not only about providing a new or the more traditional services like voice, high-speed internet, but also things like analytics, data analytics, augmented intelligence, closed loop automation coming to action. Coverage, so it's not a static slice. Actually, it can be that a network slice has a mobility character, that for instance the endpoint connected to the slice using the service at the other side of the network slice, that those things are not static but are mobile. For instance, if you are moving from location A to B, so it's important that the slice, the network slice, is devised for that. And that implies actually coverage, so that if you move, that you have the right coverage to the network, and mobility. It's the same, for instance, if you would use network slicing in a 5G context with drones as an example. Needless to say that the drone is mobile. Not only the end users or the end user equipment is not only dynamic or mobile, but we also see the density of the end user devices growing. We call that densification of the network. So it's not about your terminal, your PC, whatever at home. It are many million zillions of devices connected over that network using those network slices. So density, device density is key as well. And then the whole shift to cloud native controlled type of applications where you are not only doing the fulfillment of a service, but that you also do the control of a service, meaning the assurance, the monitoring, the healthiness of the service, including as well the optimization in the network to be able to offer at the lowest cost the expected service according to its service level agreements. And that's actually the digital future, or setting the digital future of the network. So having individual networks, the slices for new requirements using network slicing in the context of emerging, if I may, 5G services.
Okay, you touched upon automation as well. That's a very good point there. And obviously, the management of the network slice is something else that's quite important. So, what challenges do you envisage within the end-to-end orchestration and management of network slice?
So, automation is actually a necessity in this context. As we are talking about network slicing, in an end-to-end context, you need to connect actually different parts of the network. So you have the access network, you have the transport network. Access can be fixed as mobile, transport networks, core network, and all those network domains need to be connected. But all those domains do have some specific characteristics. So an access domain, mobile fixed, transport or core, they do have all specific characteristics. So the first thing you need to automate is actually that you create a network slice as a virtual overlay, if I may, over those different domains. So you need to have the knowledge of the domains, but you also need to delegate the specifics of the domain to the domain controllers, as we call them. And this is all overarched actually by what we call an orchestration function in Nokia, where actually you orchestrate based on a request to create a network slice, a network as a service, if I may, to orchestrate that amongst the different domains in the network. And that's not only setting up, actually, as I stated before, the connection, but also making sure that the whole, the entire slice is monitored, assured, so that the data is analyzed, that the service level agreements for each segment are guaranteed and are actually recovered or fine-tuned or optimized in function of time and in function of monitoring the network slice. And this all requires, together with the move to cloud controllers, the need for connecting things, orchestrating things, managing and controlling the end-to-end network slice. And then if you all sum that up, it calls out for automating that whole solution. And that's actually also what we are working on. It actually also implies a different, how to say, approach to setting up such an end-to-end slice. So actually it starts from what we call a business intent. So what do we want that network slice to achieve, the intent at the business level, which is then actually broken down, decomposed into the different domains. You need to design such an orchestrated, controlled network slice. You need to deploy it, and once it's deployed, actually you need to assure that the end-to-end slice is delivering its expected service level agreement. Another complexity is that it's multi-domain, as I stated already, but it's actually also multi-vendor. So an end-to-end network is not only built by one vendor, it's actually a mix of specific per domain or different per domain, different vendors, different parties, both hardware as software. So it's actually also important as part of this automation of connecting the domains together and orchestrating them to do that in a multi-vendor or vendor agnostic way. And that are actually the solutions we are working on. So in summary, it's about translating the service request defined in the characteristics, as I stated before, latency, throughput, reliability, mobility, geography, and that sort of things, putting all the different, what we call composable network elements together, connecting them, orchestrating them, delivering the service according to the DON design, and then actually go in an assurance mode across the different domains the network is built with.
Fantastic. Well, thank you so much, Kurt, for a wonderful insight into some of the subject matter that we'll be discussing at the Layer 123 Slicing webinar. So thank you, Kurt, again. And please do join Kurt and myself and our other esteemed speakers on the 23rd of September for the Layer 123 Slicing webinar. And we look forward to seeing you all there. Thank you, Kurt.
Thank you. You're welcome.